The modern farm must be equipped with an electrical distribution system that complies with regional safety standards, meets the needs of the farmer, and leaves room for future expansion and modernization, all while minimizing operating cost. When faced with farmstead electrical distribution planning, the individual must take the following steps to meet all of the aforementioned requirements. Number 1. Determine the demand load for each service location on the property. Number 2. Use this data to find an effective size and location for the farm's main service. Number 3. Configure the wiring of the system. And finally, number 4. Select the optimal conductors for the facility. In this video, we will discuss the logistics of using a centralized service entrance that feeds into several individual service areas on a farm.
Welcome to Bray 216, everybody. Today we will be talking about farmstead power distribution and mainly how to plan where to place the centralized load center for your farm. But first, let's start with the joke of the day. What kind of car does an electrician drive? Luke.
A Volkswagen.
You're so good. Today we will be talking about planning the central load distribution system for a farm. In our last class, we demonstrated how to calculate the individual building load demands, and since we learned that last class, they're all given today. So as you can see, for the shop, we have 180 amps. For the house, we have 200 amps. For the feed mill, we have 110 amps. And for the chicken barn, we have 75 amps. All of the service entrances...
Professor?
Oh, yes,
we
Luke.
have a building there for the well, and I've noticed that there is no amps going to that well. Why is that?
Well, that's because for buildings that have small loads, such as the well, I believe was 30 amps, it can be included into an adjacent building, such as the shop or chicken barn, in its service entrance in order to minimize the use of components in your system, therefore saving you money on your own farm one day. So using these 4 amperages, as well as their respective components, X and Y coordinates, we will be calculating the optimum location for the central service distribution panel, although that might not end up being the final place for it. So we need the X coordinates and Y coordinates, so it's laid out. This is 0, 0 at the bottom left of the house. So the X and Y are right next to each service entrance. So we can write those down. Whose phone is that? You gotta bring donuts.
Alright, I'll bring donuts.
So continuing, the feed mill has 180 and the barn has 125. So the weighted X load is the calculation of X times the number of amps. So can people do the calculations for me? Yeah.
6,300.
Next.
19,800 and 9,375.
You're a stellar student. So while I'm talking about writing down the Y values, can somebody add up the weighted X's as well as the entire load for our service?
30,875.
For the X times load is what again?
36,875.
Somebody start calculating the Y times loads.
And the feed is 13,750.
Can somebody add up this value and this value for the total load and the weighted Y value?
565 amps.
It's 22,650.
So using the 3 values across the bottom of the board, we will be able to calculate the central load distribution center coordinates. So how do you guys think that we will go about finding the X coordinates using these 2 values and the Y coordinate using these 2 values, as well as the total loads? We got an answer? Yep.
are we gonna multiply the x value by the x and load value, and then divide it by the sum of the loads?
That's close, but you're off by a little bit.
Shoot.
So for the x coordinate of the load center, it'll be equal to the weighted x coordinate of each building summed, so x load total, over the total load. So with some canceling out, you end up with just an x value for your x load center. So for ours, it will be 30. Somebody give me answers for both of those.
The x value is going to be 65.3.
Good job. And for our y value,
The y value will be 48.9. No, yes it is. Yeah.
sure?
Oh,
Yeah.
I'm positive.
Yeah.
Okay. And using these two values, we find that our optimum centralized load center is in the middle of our house. So, whenever you're planning your farmstead, whenever things like this happen, such as the load center being in the middle of the house, or if it were to be in the middle of the driveway, you must use good judgment in order to properly locate it. So in this case, the best idea may be to locate your centralized load center, since it should be here in the middle of the house, which is closest to the house's service entrance panel, to put it next to the service entrance panel in a small outlaying shaft. Does anybody have any questions? Yeah?
Why is it best to use this central distribution approach to finding the center?
Does anybody else in the class know this answer?
Well, I know one. It's to reduce conductor use.
Reduce conductor use, which will in turn save us money, right?
Exactly. It's all about the.
Yes?
And you can't forget about safety, right?
Yep. Putting your centralized load center in one spot that the power company can agree with you on can make it the safest for both your workers, yourself, as well as your animals.
Yo, Professor Dirksen, what's the deal, man? Why doesn't the well have its own circuit?
I'll have to get back to you on that one.